Hello, AP Environmental Science students, and welcome to our last of the review sessions. We're going to finish up Unit 7 today. Next week, we will still be meeting again, and we're going to have some practice exams next week, but more information on that later. So let's take a look again, just a reminder, our exam is May 18th, and you can see the exam times there and our 2 FRQ questions that we've been practicing. So here's where we're going to go today to finish up Unit 7. So Ms. Fassler did a wonderful job yesterday talking to you about some outdoor air pollutants. And today we're going to focus on some strategies to maybe mitigate or prevent some of that. And then we're also going to look at indoor air pollution. So we're going to look first at indoor air pollutants themselves, reduction of air pollutants, acid rain, and noise pollution. I'm not going to go in that exact order, but that's how it's listed in the curriculum. And then we're also going to practice science practice number 4, scientific experiments. I'm going to show you several clips of scientists doing scientific work, experiments. I'm also going to give you a few chances to kind of describe some potential scientific methods as we go along here. All right, so what do we need to know about our first topic? 7.7 is acid rain. So by the end of this section, you should be able to describe what acid rain is and the effects of the acid rain on the environment. You'll notice that it says acid deposition here. That's just a broader term that can encompass other things other than rain. So snow, sleet, dry, fallout. So acid deposition is just a broader term. Acid rain is more specific. All right, so to get there, we'll talk about the causes and then the effects both on humans and the environment. So Ms. Fassler talked to you about SOx and NOx emissions last time through the burning of fossil fuels and other human activities. We're going to start by looking at those emissions and how they create acid rain. So that can occur naturally. If you think about how SOx might be emitted from something like a volcano, we could have natural acid rain. But what we're going to focus on is the anthropogenic sources of that. And for us, this is a secondary air pollutant. While SOx and NOx might be considered primary, the acid deposition that comes as a result of that is a secondary air pollutant because it's something that's forming through a chemical reaction after the primary is emitted. So what is causing acid rain? This is our SOx and our NOx. So once the SOx and NOx enter the atmosphere, they're going to mix with water to create nitric and sulfuric acid. So in terms of the main sources, so Ms. Fassler mentioned yesterday that a lot of NOx comes from motor vehicle emissions and coal burning power plant emissions. And then SOx mainly is just the coal-fired power plants. Why do we not see as much SOx from motor vehicles? Well, because there's been some concerted effort with legislation and some practices to reduce the amount of sulfur in gasoline. So once these SOx and NOx are emitted, we make the acid rain or the acid deposition, and it can fall down in rural areas and city areas and water and on land and kind of get transported around for a big wider effect than you would think. So let's look at some effects. Well, first of all, the people who are going to be most affected by it are communities that are downwind from coal burning power plants. So if this is my coal-fired power plant, wind is going to blow this way downwind, and this community is going to be most affected. It can corrode man-made structures and buildings. In particular, things like this. The statue is made of limestone, and the acid rain can deteriorate those structures. What does it do to the environment? Well, acidic rain can cause damage to tree leaves and needles, so to reduce the ability of the tree to go through photosynthesis and can cause the tree to die. It can percolate and infiltrate down into the groundwater and affect the groundwater sources, or it could just run off into surface waters. So it can have a wide array of effects once it hits the ground. And once it goes into the soils, two things can happen. Number one, it can increase aluminum toxicity. Acidic soils make aluminum more soluble and more easily taken up by roots, and that can cause some damage to plants. And it can also affect the availability of some nutrients in the soil. That's why farmers always want to test the pH of their soils before they plant their crops. So let's look at the effect on organisms in particular. So this is the critical pH level for aquatic organisms. This is just a chart showing several aquatic organisms. So let's just take the crayfish, for example. This is saying that below 5.5, the crayfish will not do so well. So this is kind of the critical pH levels that we don't want to go below. So if we think about these things, this is really going back to that concept of range of tolerance. Ms. Fassler talked about that several times in her review sessions, that we have the abiotic factors, whether it's pH or temperature, salinity, there's some kind of abiotic factor in the environment, and there's an optimal range for the species. So here in the middle, this is the optimum temperature range for these fish. They like this temperature, they function perfectly in this temperature. But too high or too low, you get into this zone of stress where they're not functioning properly. And then you get into these zones of intolerance on the final ends where they just cannot live there. So if we think about pH, the same kind of influences. Because pH is so easily measured, I mean, we've all done experiments in which we've measured pH. Think of an experimental design that you could do. Perhaps what kind of experiment could you do to study the effects of lower pH on things like plants? What kind of data would you collect? What would be your variables? What might be your control group? So, excuse me, this process of looking at an environmental problem like acid rain, if you can think of a way to quantify or measure how that affects the environment, you should always be practicing these experimental design processes. What kind of tools would you need? What kind of setup would you need? How would you control for other effects that you didn't intend? Or how would you replicate your data? So we're going to do this several times today to talk about a scenario and then say, could we pull back and think, well, how could we quantify an experiment about this phenomenon? So here's a little clip from National Geographic that summarizes acid rain.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.
So that's just a nice little overview of the idea of acid rain. So let's say we did want to reduce the amount of acid rain. One of the things we might want to think about is how do we reduce the amount of SOx that's entering the atmosphere. So that's what 7.6 is about. 7.6 is about explaining how air pollutants can be reduced at the source as they're being emitted, not in terms of cleaning them up later, but how could we reduce the amount of pollutants coming from the source? We're going to look at two systems coming from cars, so vapor recovery systems and catalytic converters. But we're going to start by looking at two devices that are often used in coal-fired power plants, which are scrubbers and electrostatic precipitators. So let's start with the scrubber. When you think of a scrubber, you should think of a little spray mist bottle like the one in the picture here. So a scrubber system removes or scrubs the SOx and some particulate matter emissions from the gas from a coal-fired power plant and other factories as well. And how does it do it? It sprays this wet slurry of limestone, which is high in calcium carbonate, into that gas, and it causes the sulfur to kind of be collected and drop out to the bottom. So there's less sulfur coming out of the top. It doesn't get rid of all of it, but it reduces a lot of it. And then the sulfur can be collected in a different form and stored somewhere in a landfill taken somewhere else. So that's how a scrubber works. Here is an example of a factory in India before and after they installed a scrubber. Now, you wouldn't be able to see really the decrease in SOx, but what you can see is a really strong decrease in the amount of particulate matter. So you can see it was a dramatic effect after they installed it. And if we look at our sulfur dioxide emissions in the United States between 1980 and 2018, we see a 91% decrease. So all of the regulations and policies that the United States has been putting into play have had a dramatic effect on the amount of sulfur in the air. So another device that is often used at coal-fired power plants is an electrostatic precipitator. So in essence, what happens is the smoke comes in through the bottom. The particles are charged, so there's an electrical charge given to them that attaches them to the plate, and then they fall down. So again, you're collecting them into the bottom that can be hauled off. So it works by creating an electrostatic charge, which attaches to the particulates. And as those particulates become charged, they attract to the metal plates and then fall down as dust. Whenever I talk about this to my students, I always give the analogy of taking a balloon and rubbing it against some fuzzy hair and then holding it over some pieces of paper. The little pieces of paper will get sucked onto the balloon. Very similar device, electrostatic precipitator. Really, really going to reduce the amount of particulate matter, PM, from the air. And if we look at PM 2.5, remember this is the number that comes after the PM is about its size. So the smaller the PM number, the more likely it is to get into your bloodstream through your lungs. And we can see there's been about a 40% decrease in this tiny amount or this tiny size particulate matter since 2000. All right, so now let's switch over to cars. On a car, there's a device called a catalytic converter. And the catalytic converter reduces the emissions of 3 harmful compounds in the exhaust. So carbon monoxide, NOx, and then some hydrocarbons. So what does it do is as the exhaust from the engine comes through the catalytic converter, some chemistry goes on here, which you do not need to know for the purposes of the exam, results in water, carbon dioxide, and nitrogen gas. It doesn't completely remove the NOx or the carbon monoxide or the hydrocarbons, but it greatly reduces it. So catalytic converters have had a profound effect on the amount of these things in the atmosphere. And while that is not the only thing we've done to reduce carbon monoxide levels, we can see that the amount of carbon monoxide from 1980 to 2018 has had an 83% decrease in the United States. All right, so the second device that's used with vehicles is vapor recovery. So we've all pumped gas at some point, maybe. And if you're pumping gas, you will probably have noticed the smell that's coming out of that. That is the volatile organic compounds, the VOCs that Ms. Fassler talked about last time. So there's a certain nozzle that will actually prevent those fumes from getting into the atmosphere. They actually suck them back up and can store them underground. So why do we care about this? Is because VOCs are really, really dangerous in terms of their ability to form photochemical smog in some of our urban areas. So to reduce photochemical smog, one way to do that is to reduce the amount of VOCs coming from gas tanks. You can also reduce it by when the truck delivers the gasoline to the gas station. That's another chance for the vapor to get escaped, and they can also do that as well when the gas is delivered. So anytime gas is going in or out of the underground tank, that's when you want to be mindful of minimizing the amount of VOCs that get into the air. All right, so that kind of takes us through outdoor air pollution. Ms. Fassler started the conversation the other day, and I kind of wrapped it up with a few strategies to reduce those pollution. But now we're going to go inside. And sometimes indoor air pollution can be more dangerous than outdoor air pollution in certain cases. And there's some things that we just don't think about on a regular basis. We think about factory smoke and pollution because we can see that it's visible to us. But a lot of times the indoor air quality problems in our homes are invisible. So by the end of this section, we're going to, again, the pattern is the same. We're going to identify the pollutants and then describe their effects. So we will look at both natural and anthropogenic sources of indoor air pollution, and then look at health effects on of these pollutions on our body. So before we do that, I want to show you a little clip. And as you watch this, I want you to think about how you could design an experiment based on what you learn here. So this is going to present a scenario about indoor air pollution, and think about how could you go about designing an experiment to test something from this video.
Air pollution carries significant risk to human health, and children are particularly vulnerable. The invisible pollutants inside our buildings can lead to much higher pollution levels. However, work by Ishan Tripathi, a high school student and in the class of MIT 2023, and Joseph Lequatre of Cornell University, seeks to draw attention to the risk of indoor air pollution to children's health. Indoor air pollution affects adults and children differently. Children spend most of their time indoors in the child breathing zone, an area defined as being up to 1 meter from the floor. This means that seemingly harmless activities in the home, such as laying carpets or painting rooms, can have a different impact on children and thus cause serious health issues. Current ventilation systems work on the assumption of equal distribution of pollutants. Through their research, Tripathi and Lequatre have shown that different pollutants can occur in different layers in the air. They also found that when pollutants such as dust are disturbed, they can be resuspended in the air. The health problems caused by indoor air pollution are severe, but also avoidable. One of the best methods of prevention is proper ventilation. When combined with greater awareness and understanding of the risks, these simple measures are sufficient enough to help reduce risk to children of exposure to indoor air pollutants.
So thinking about that, what kind of experiment could you design? Well, one of the things that I do with my students is one that's pretty common, where we can take a Petri dish and put a thin layer of Vaseline on that Petri dish and set it out in different places to see how much particulate matter sticks onto the Petri dish. So one of the questions that we always look at is, how does the height affect the amount of particulate matter pollution in a home? So you could take these Petri dishes and put them in different heights in your home. And if every student does that in several heights, we have a good amount of data to analyze, even though the houses are different. So, thinking about what's your independent variable, where our independent variable here would be the height that we place it at. What's your dependent variable would be the amount of PM, the amount of particulate matter that you collect. What are your methods? Just talked about that a little bit of putting the different Petri dishes at different heights in your home for maybe 24 hours and then stopping to count them. What factors will you keep constant? Well, you may want to keep constant the amount of petroleum jelly you use, or the size of the Petri dish, or how long it's been exposed to the air before you close it up. So you want to keep a lot of those things constant. What will be your control? Well, I think it would be really useful to take one of the Petri dishes and keep it sealed and don't open it up, because there naturally might be some particulate matter found in the petroleum jelly or from when you were applying it in the first place. So having one that's not exposed to indoor air. And then what tools would you use to quantify your observations? Well, you probably would want a microscope or a hand lens or a light, something that you could easily see and count the particulate matter. How would you analyze your data? What kind of graph would you generate? What kind of data analysis or statistics would you use? So these are the questions that you want to think about, again, anytime you're presented with a question that you want to answer scientifically. So let's move to carbon monoxide now. Carbon monoxide is an asphyxiant, and Ms. Fassler talked about this the other day, about how it binds with hemoglobin and prevents our body from distributing oxygen to our brain and other places in the body. So this carbon monoxide really comes from burning fossil fuels or biomass. It's colorless, it's odorless, so it's very dangerous, it can't be detected. And again, it's highly toxic because it binds with hemoglobin. This is a particularly harmful event in some developing countries where indoor cooking or heating has to happen, and there might be less ventilation. So we're going to take a look at a little clip in a minute about this particular problem and some ways to solve it. But this smoke that's happening here, not only is there carbon monoxide, but you've got those particulate matter that could get into your lungs and into your bloodstream. This is a little screenshot from Ms. Fassler's talk yesterday. So how could we prevent this? Would there be a way to prevent this from the source, or a way to mitigate the effects? Well, one thing to do would be switch to a cleaner fuel source, or to improve the ventilation at homes. But remember that all of these solutions probably have a cost associated with it, and you may want to think about how do socioeconomic factors affect that ability to make that change. One thing to think about, and I always think about when I think about carbon dioxide, is the use of generators. Here in Florida and along the East Coast, when we have hurricanes and the power goes out, some people will use generators to provide electricity. And a lot of those generators run on gasoline. Well, unfortunately, sometimes people will bring those generators inside and they can experience carbon monoxide poisoning. So there's a big difference between a developed country using a generator inside for a hurricane versus someone who is cooking and heating their home on a daily basis. So let's take a look at that particular issue. This is from the UN. So now let's switch over to a natural source of indoor air pollutant, which is mold. So mold spores are everywhere. And so a lot of places they land, they just can't grow. But where do they like to grow? In moist, warm conditions, commonly in poorly ventilated areas where it's really humid. A lot of times this happens in a bathroom or in some internal walls where there's a high humidity and not a lot of ventilation. These spores can cause some allergic reactions, asthma, and other respiratory issues. And there's really no way to eliminate all the mold or mold spores. They're kind of ubiquitous all over the place. How you control mold is by improving the ventilation in an area, or just reducing the moisture content in an area. Next, we're going to go to another anthropogenic source, which is asbestos. So asbestos is a type of particulate matter pollution, and it's a naturally occurring material that has these tiny little microscopic fibers, very, very tiny, and they have a unique set of properties. They're very fire resistant and strong. So we've used them a lot for construction materials like insulation or as a fire retardant. Unfortunately, once those fibers become inhaled into the lungs, it can cause several cancers and diseases, including mesothelioma. Here are two pictures of some asbestos. So you can see the insulation in a house, old insulation, old hot water pipes used to be insulated with asbestos. It's not something that's used anymore. So you're typically only going to find it in older homes or older buildings. This was a part of an FRQ a couple of years ago, and the question asked the students to identify the source of the indoor air pollutant and one method for reducing exposure. And so for asbestos, again, the building materials, insulation, and then ways to reduce exposure, safely removing it, sealing it up so it can't affect you, or just leaving it undisturbed, because it's when it's removed and disturbed that those particles get into the air and can cause problems. All right, the next anthropogenic source of indoor air pollution are VOCs. And Ms. Fassler talked a lot about these yesterday in terms of being part of photochemical smog, those volatile organic compounds. What we're going to talk about today is how VOCs are also emitted indoors from things like furniture, paneling, carpets, adhesive, glues, paints. You know, when you open up a can of paint, you can easily smell that smell. That's a VOC. So there's a lot of things that happen in our homes that we don't think about that can increase the amount of VOCs inside. Why do we care? Well, eye, nose, and throat irritation, headaches, damage to liver, kidney, and central nervous system. So it definitely has some very negative health effects. So one type of VOC is formaldehyde. And one place you can find formaldehyde is in pressed particle board. So instead of using a full piece of wood, you can create particle board by gluing together little chips of wood, almost like pulp wood. And so it's kind of Frankenstein together by little pieces of wood. Well, the glue and adhesives and chemicals used to bind all this particle board can emit VOCs. So a couple of years ago, I was at a state fair here in Florida, and one of the things they had there was a big mobile home that you could go in and tour, you know, to show off, I don't know, new mobile homes. And so we went through there to look around, and I happened to see this sign that was stuck onto the bathroom counter, the kitchen counter, inside the mobile home. So I'm going to read you part of this, and we'll talk about it some more. Some of the building materials used in this home emit formaldehyde. Eyes, nose, and throat irritation, headache, nausea, and a variety of asthma-like symptoms, including shortness of breath, have been reported as a result of formaldehyde exposure. Elderly persons and young children, as well as anyone with a history of asthma, allergies, or lung problems, may be at greater risk. Research is continuing on the possible long-term effects of exposure to formaldehyde. So we kind of go, okay, well, thanks for giving me that little piece of information, but what does it have to do with a mobile home? The next paragraph answers that. Reduced ventilation resulting from energy efficiency standards may allow formaldehyde and other contaminants to accumulate in the indoor air. Additional ventilation to dilute the indoor air may be obtained from a passive or mechanical ventilation system offered by the manufacturer. So it's really interesting here that it's almost like a health warning for a new home. Because we build homes with a lot of these processed particle board woods and carpets and adhesives that use these chemicals, combine that with the fact that we make homes very, very well insulated now. We use lots of insulation, a home is very energy efficient. Well, that kind of is good for our heating and cooling costs, but it's bad because any air pollution like formaldehyde that comes into the home stays in the home. So anyway, I thought that was a really interesting case of a VOC coming to play. All right, so another air pollution is lead from paints. So even though paint is a liquid, we don't think of that being an air pollutant, what can happen is old paints used to have lead in them. We don't do that anymore, so this is only going to be a problem again in old buildings and old houses. But as that paint starts to peel off, it can create little particulate matter and become inhaled. And anytime you are remodeling or demolishing older homes with older paint, that's when it becomes a problem. The next one we're going to look is radon. Radon is a natural indoor air pollutant. This is a naturally forming radioactive gas that comes from the decay of uranium in the rocks in the ground. So the uranium in the soil and in the rocks naturally decays over time. And one of its products is radon. And that radon can get into the house and again, kind of be trapped in and cause some very dangerous effects. Not everywhere in the United States experiences the same threat to radon. Here where I am in North Florida, the risk is a little bit lower than if I were up in some of the northern states. So it definitely has to do with the geology of the soil and the ground underneath. So radon typically is going to move up through cracks in the foundation or the basement because that's what's coming in contact with the ground. And once it gets in there, it can build up just like any other indoor air pollution. It could also infiltrate cracks into groundwater pipes, so it could enter the water as well. Unfortunately, radon is the second leading cause of lung cancer in America. So this is a very big threat. That's why we typically see radon detecting kits or radon detectors in homes to monitor that. So taking all that into consideration, the American Lung Association gave a list of guidelines to improve the indoor air quality, and I thought they were worth just looking at. I mean, I know I don't operate a coal-fired power plant, so I don't really have the opportunity to buy a scrubber and stick it on the smokestack. But I do live in this house, and I do have the ability to change things in my own home to improve the air quality in my own home. So here are some of their recommendations. Make it a smoke-free zone. Tobacco smoke is very, very dangerous. That secondhand smoke is very dangerous. It's particulate matter and all of those other chemicals involved. Test it for radon. You know, radon is colorless, tasteless, odorless. That's linked to lung cancer, like we said. So testing for radon would be really useful. Fixing leaks to discourage mold growth. Remember, we said mold grows in really damp, unventilated areas. So, and then take a look at the cleaning supplies you use. Think about what kind of cleaning supplies are producing VOCs, for example, or the pesticides that you might use in your home. Dehumidifiers are an air conditioner to keep the humidity levels low. Because remember, anytime that humidity level goes pretty high, that's when you're going to have more mold growth. Then it talks about buying an air purifier that could capture some of those air pollutants, those air particles, and then to avoid burning wood inside. So this is that indoor air pollution that we saw coming from cooking and heating using biomass inside. So some really good recommendations from the American Lung Association. All right, we're going to end today with noise pollution. Noise pollution is one of those things we really don't think about until we hear it, and sometimes it can have some very dramatic effects. So to get there, we're going to talk about the anthropogenic sources of noise pollution and their effects both on wildlife and humans. All right, so what are some sources? I think we all can kind of figure out what the sources are, and the fact that they're probably going to be higher in urban areas. Transportation, so cars, trains, airplanes. You know, this is a good example of a highway here with lots of noise pollution, and this wall has been built as kind of a sound barrier to the neighborhood on the other side of the wall. Construction, we've all seen construction sites that are particularly noisy, and then just a lot of other domestic and industrial activity that goes on that create kind of this ambient background loud noise throughout our lives. Well, why do we care? Not only does it cause physiological stress and loss of sleep, maybe, but it also can affect your hearing, and you can have hearing loss. But what we're going to focus our attention on right now is the effect on wildlife. So it can also cause stress in these wildlife, but it can also get in the way of the sounds that they use for communication or for hunting. And we'll look at little video clips talking about both of those examples. It could damage their hearing just like it could damage ours. And it could affect their migratory routes. So think about whale migration or bird migration. All right, so I'm going to show you a clip about some bats. So bats use echolocation, a type of sound, to hunt with. So as you watch this experiment, think about how you would design an experiment based on what you learned here. How could you perhaps design an experiment to study the effects of noise pollution on bats?
Bats are nocturnal hunters, and I was really fascinated by sonar, this ability to use sound to navigate in the darkness. And as I learned more about bats, I started being interested in the prey of bats and insects, and that led into studying bat-moth interactions, which is an arms race, a coevolutionary battle that's been going on for more than 60 million years.
An amazing aspect of the dynamic battle between bats and moths is that they use sound in the hunt. To find prey, bats rely on echolocation. They produce high-frequency calls and listen to the echoes from their targets to find their position. Having long been on the bat menu, moths have evolved strategies to avoid being eaten.
There's a lot of different anti-bat strategies, and the one we're studying here is sound production, ultrasound production above the level of human hearing. They have ears to hear bats coming, and then producing their own ultrasound back at the bats.
So we've got a kind of a cool situation there where hunting and avoiding being eaten are all involving sound. Sound is such a critical part of those moths' lives and the bats' lives. Well, we put some noise pollution in there, and how does that affect it? Think about how bats might react to if all of a sudden a fossil fuel extraction or drilling site came into an area, how that might affect the noise pollution in the area and the wildlife around there. And famously, the other place where noise pollution is dangerous is with marine mammals. So there are some clear research that looks at the connections between kind of marine noise pollution and the migratory ability of whales. So as we watch this experiment or this video, I want you to think again, can you analyze the experiment that they did on the squid? Can you think about what their variables were, how they set up the experiment, what kind of data they collected? So let's look at an experiment on noise pollution with marine organisms.
These whales.
Whales talk to each other through a complex language of clicks and whistles. These sounds help them to navigate and communicate. Man-made noises like sonar can disrupt this communication and disorientate them.
We know how sensitive people are to whales and dolphins, totem animals, and they were seeing them washed on shore by this human activity for the first time. So this really helped understanding that this noise could have a detrimental effect.
Since this incident, the use of sonar has been associated with a large number of whale strandings around the world. But while beached whales continue to grab the headlines, Michelle was keen to understand if other creatures were experiencing the same fate.
A group of giant squids were found stranded on the beach. The post-mortem analysis didn't show any cause of the death.
What he was about to discover would change scientists' understanding of the effects of ocean noise pollution.
This group of experts realized that a geophysics experiment using a high-energy sound that was performed a few days before this event.
Oil prospecting ships had unknowingly disturbed the ecosystem below them.
We decided in our laboratory to recreate this situation, and we found this massive acoustic trauma when we exposed this animal to sound.
Although squid don't have ears, their bodies contain small organs called statocysts, which are lined with noise-sensitive hairs. In his lab, Michel and his team discovered that even low-intensity sounds destroy these hairs and knock out the squid's balance.
We went through the idea that it was only affecting a few species, the whales and the dolphins, to invertebrates and fish, and we are speaking about thousands of species. So we cannot anymore consider the effect of noise as species-specific, but consider it as a global effect to the whole marine environment.
All right, so let's do a little quick check for understanding about what we've talked about today. So this question says, scientists have observed that the health of people living in moderately developed regions, which have developed transportation and industry but lack environmental control measures, is more likely to be affected by urban outdoor pollution than indoor air pollution. Which of the following conclusions can be drawn from the data presented in the graphs? So I'll give you about 30 seconds to take a look at that and pick an answer. All right, so our answer is A. In moderately developed regions such as China and Latin America, an individual's health is more likely to be affected by outdoor than by indoor. All right, let's go to the second question about this, about the same graph. Which of the following activities would most likely account for the levels of indoor air pollution in sub-Saharan Africa as shown on the graph? And our correct answer is B here. Use of biomass fuel such as or sources such as wood and charcoal for cooking. All right, let's take a look at this last question together. It says, over a 3-year period, a city's Environmental Protection Department measured the particulate matter, PM 2.5, in a 10 square mile area around one of the city's coal-fired power plants. The annual mean level of PM 2.5 measured was 20 micrograms per cubic meter over the 3-year study period. The National Ambient Air Quality Standards for PM 2.5 is an annual mean level of 12 micrograms per cubic meter, averaged over 3 years. The city instructs the manager of the power plant to propose a plan to aid the city in meeting the NAAQS for PM 2.5 in the area around the power plant over the next 10 years. Which of the following would be the most effective plan for the manager to propose to the city? And you should have put your eyeballs on electrostatic precipitator. That's going to be our best effective measure for particulate matter. All right, so let's try one more time to practice these scientific experimentation skills. So remember, you're going to do things like identifying a hypothesis or a question, identifying research methods, designs, or measures used, describe those things. This part is not obsessed because that's what you would do in class when you actually collect data yourself. And then maybe explain modifications to an experimental procedure that will alter the results. So let's take a look at this example here. You are the property manager for a large apartment complex. Several residents have reported issues of mold growing in their bathrooms. You know that a lack of ventilation can increase the moisture humidity of indoor air, which is often associated with the growth of mold, and want to determine if you can reduce the moisture content of the air. The local EPA office suggests you try desiccants, which are dehydrating products that absorb moisture out of the air. You want to know how well the desiccant products can reduce humidity levels, which you can measure with a hygrometer. So take about 30 seconds or so and think if you could answer these 5 questions. All right, so if we just look at the scientific question, well, the question is how well these products can reduce the humidity levels. That's our goal here. And there's many different experiments that you could design to accomplish this. I'll describe the one that I thought of. So I thought of taking 4 containers, container A, container B, container C, and container D, sealed containers, and squirting water in there until I got it to about a 50% humidity, and I could measure those humidity levels with a hygrometer. So I've got 4 equal containers, equal size, shape, materials, all that. They all have the same level of humidity now. So in container A, I don't put anything in there. That's just, there's no desiccant package at all. In B, I put 1 desiccant package. In C, I put 2, and D, I put 3. So that's the experiment that I kind of thought of testing how well these desiccants can reduce the humidity. So if I do that in written form, I said, I will set up 4 different sealed containers, each with a starting humidity of 50% as measured with the hygrometer. Container A will not have a desiccant package, while containers B, C, and D will have 1, 2, and 3 desiccant packages respectively. I will measure the humidity of each box using the hygrometer once a day for 2 weeks. In terms of what is the independent variable, well, that would be my number of packages. That's the thing that I'm changing. What is resulting from that is the percent humidity. And my control group is clearly container A that contains no desiccant package. So this is an example of how you can look at an issue such as mold and come up with an experiment to try to learn something more about it, especially its prevention. All right, so what did we do today? Talked about lots of indoor air pollutants. We talked about how to reduce those air pollutants with things like the scrubbers and the electrostatic precipitators and the vapor recovery systems and the catalytic converter. Then we looked at acid rain. And finally, noise pollution. And throughout each of those, we try to practice some part of scientific practice number 4 on experimentation. So that is all of our review for the first 7 units, but we still have next week to go. So here's what we're going to be doing next week. On Monday and Wednesday, you're going to have a full practice exams. Remember, our exams are 2 questions. So on Monday, you're going to have a full practice exam here with us live. We'll give you 2 questions, we'll time it out, give you the time to answer it just like you would on the regular exam. So that happens on Monday. On Tuesday, we'll go over those questions. And then Wednesday, you'll have a whole new chance to practice 2 more questions. And then on Thursday, we'll go over those answers, okay? So during those discussions, we'll highlight big misconceptions and misunderstandings that have happened in the past. What are the key practices and skills you need to answer those questions? We'll look at those task verbs that we've been looking at all through the course of the review. And then we'll talk about we'll review the testing procedures. So about your exam ID, your exam ticket, your e-ticket, what time to show up for the exam, how do you prepare for it? We'll go over those things as well. And then we'll just give some final tips and suggestions from myself and Ms. Fassler. We're both going to generate some best practice tips for doing both types of the FRQ, the experimental design FRQ and the propose a solution to an environmental problem. So hopefully we will see you next week. Thanks for watching and have a good weekend. Bye, everybody.